In our polymerization podcast, we're going to learn what polymerization is and how it's used in your everyday life. All right, so polymers, if we were to look at the actual word poly, means many. These are large molecules that consist of small repeating units called monomers, mono for one. So if we take a bunch of single units and we put them together back to back to back, we're going to wind up with a long chain or a polymer. These guys have wide industrial uses. You might have also heard of a polymer when we talk about biological macromolecules such as proteins, which are polymers made up of a single repeating unit of amino acids. Those are the monomers. In order to get this, you're going to have an alkene undergo an addition reaction. We haven't talked about addition reactions before, and I'm going to show you slightly, we'll preview what that means, but don't worry about it if you don't quite get the reaction yet. Your double bonds are going to be broken so that you have now a single bond and places for the carbons to bond with one another. This is how you get a long chain of these monomers. A lot of times to make polymers in chemistry, we need high temperatures and high pressures. So let's take a look at what this would look like. So let's say we broke the double bond on the alkene. What we would wind up with is a place on both of these carbons for a bond. Notice the place on a bond here. Well, if I did that to two monomers, I'm going to wind up with carbons that have the ability to create another single bond. So now, remember that these were two different monomers. Now we can have a shared bond between them, and we've created a long chain of hydrocarbons with single bonds. But it takes breaking that double bond in an addition reaction to create our polymer and to bring those two monomers together. Again, if this is not quite crystal clear, we're going to revisit this topic later this unit. We see polymers a lot when we talk about plastics. Plastics are all polymers of hydrocarbons. So for example, and think about the last time you recycled something, it had that little triangle on it and it had a number in it. That number is its recycling code, and that will tell us what the polymer's name is, which can also tell us what the monomer is for that polymer. So if you have a recycling code 1, you may see PET written on that plastic. That's polyethylene terephthalate. So this is actually the repeating structure in any plastics that have a recycling code of 1. So that monomer, and it's not small, but that monomer is repeated over and over and over again. That's what the subscript tells us, that you get a certain number of these. Could be hundreds, could be thousands, but that's the repeating unit. And we see anything with recycling code 1 or PET used in fleece clothing, plastic bottles, carpeting, and so on. Another one I want to point out is recycling code number 4, LDPE, or low density polyethylene. Okay, so polyethylene is started as a 2-carbon alkene, ethene. And just in that reaction that we talked about on the last page, we break the double bond, and then we can connect these ethylene molecules one after another, and that's what makes up trash bags. The recycling code also tells us our ability or our ease to which we can melt down a particular plastic, which is what's going to dictate whether or not we can recycle it easily or not. All right, so besides boring old plastics, how do we see polymers used in medicine and dentistry? Vinyl chloride, which is this alkene, is used in polyvinyl chloride, or PVC. We have PVC piping in our homes, in our plumbing, but we also see this in blood bags and any tubing that you might have to attach to your patient to pass medications or blood transfusions. Propene is an alkene that makes up polypropylene, so many propenes, and propylene is the common name for propene, if you're wondering where that came from. We see that in plastic syringes. Tetrafluoroethylene is polytetrafluoroethylene, also known as Teflon. That's what your dental floss is coated in. Sometimes your cooking pans are coated in that. That's a non-stick surface. So we really see polymers in our everyday life a lot. Thank you, chemistry.